Hello, everybody. My name's Norm Johansson. With me here is Steve Roberts. We are both senior software engineers at AWS, where we focus on all the AWS.NET developer tools. So if you're writing .NET applications on AWS, you are most likely using some of the tools that Steve and I work on. Thank you very much. So today what we're going to cover is our view, what is the current state of .NET and .NET Core. We're going to briefly talk about some of the developer tools that Steve and I work on. And then we're going to move into what we're calling is our .NET Core tooling trilogy, because everybody loves a trilogy. This is the toolings that we've added to make .NET Core work fairly easy for some of the services out there. And the first one we're going to take a look at is .NET Web Applications with Elastic Beanstalk. We're going to talk about serverless .NET Core and AWS Lambda. And new today, we just launched container-based .NET Core application support with Amazon Elastic Container Services. So we're going to go into that. So if you've been following our blog and our Twitter handle, you've probably seen the last year where we have been talking a lot about .NET Core. And the reason we've been talking about .NET Core so much is we really believe that .NET Core is going to be the future for .NET development in the cloud and on servers. And the reason we see that is if you look in the past year and a half since .NET Core has been GA'd, it has expanded very quickly. We've had 3 large releases. We had the 1.0, 1.1, and the 2.0 release a couple months ago. And that 2.0 release really helped mature the platform. It added a lot more APIs. It solved a lot of the usability issues that were in .NET Core 1.0, and it is growing fast. And they can do that because the way .NET Core has been designed, it allows you to have that side-by-side install, so that they can have multiple versions on the applications or on the machines and not worry that this is going to break all of the .NET applications on the box. Unlike .NET Framework, you always just have that one version on the machine, and it affects every .NET application running on the machine, so the .NET team has a hard time moving that forward without breaking in existing users. In .NET Core, you have that side-by-side install, and when you develop .NET Core applications, you're always targeting a particular major version. So it gives them more flexibility in evolving the platform. .NET Core also has the cross-platform support, which we've been taking advantage here at AWS with our Lambda support. And another example of how it's the future is the ASP.NET Core and any framework core. Those frameworks have been getting a lot of improvements, a lot of new features over the past year. But if you look at their inverse, the parallels of that, ASP.NET MVC and Entity Framework, those have not had any significant updates since early 2015. So over 2 years, those have not had any updates to it. The EC2 Windows team is continually working on getting Windows working great on AWS and the latest SQL Server, because even though you're using .NET Core, that doesn't mean you're not using Windows. And .NET Core and Windows work really well together. Sandy Carter has a session tomorrow at the MGM. Is that right, Steve? Yeah. And she's going to give the State of the Union for enterprise workloads, and she's going to talk a lot about the new features that EC2 Windows team has been working on. So we crammed our talk with too much stuff, so we're going to kind of skip through a lot of this slide here. I just really want to talk about is the last 2 bullets here. The AWS tools for Microsoft Visual Studio Team Services. This is a new tool that we launched this summer. Was it August? August? So this allows you, if you're already using VSTS or TFS, to be able to use our tasks that we have developed to be able to use your same build system but push your work to AWS. Steve and I have another session on that tomorrow where we're going to dive deep in how that works. So if you are a VSTS or TFS user, I highly recommend checking out that session. And new today, we just pushed it out just a couple hours ago actually, is the extensions for the .NET CLI. Now what this is actually came out last year as part of our Lambda release. When we released Lambda last year, we had all the Visual Studio plugin work, but we knew this is .NET Core, and there's a lot of users who are going to use .NET Core outside of Visual Studios on Macs and Linux, also using Visual Studio Code, or they want to also be able to script and automate their deployment. So we wanted to make sure all of that code that we put in Visual Studio to help deployment, you could easily use outside of Visual Studio. So we put it in a command line extension so that you could use it as part of the .NET CLI. So you could go just from the Visual Studio, you could do deployment, and then you can transition to the command line, and you could say .NET Lambda deploy function. And so we just released a whole repository on this, expanding our support. So this is our GitHub repository out here. If you scroll down here, also, by the way, this package we just released is being built with our code build service, which code build just added a badge support, so we added that on there. And if we scroll down to our supported services, we've expanded that Lambda to now also include Elastic Beanstalk and ECS. So that's going to be our trilogy we're going to be talking about today, is those 3 services. So I highly recommend checking out this GitHub repository. If you have any feedback or suggestions on how we can improve it, we're going to talk a lot more about how that works today. All right, now on to our .NET Core tooling trilogy. And first up is Beanstalk. Now, Beanstalk, we have had support for Beanstalk for quite a long time. I think we added that in 2012.
Yeah.
Right. So, and we've demoed this many times here at reInvent, in fact. So we're not going to really dive too much into that. We just want to show a little bit about the new things we added and how you can use .NET Core applications in there. And now, Beanstalk is also one of the easiest ways to get started with .NET and AWS, because you basically just give it your package bundle, and it takes care of setting up your EC2 instances, auto-scaling, and load balancers. And it also has .NET Core and .NET Framework support on it. So we have on .NET Core 1.0, 1.1, and 2.0, and we also have the .NET Framework as well. So Steve, let's do a demo there.
Okay. So here we are in Visual Studio 2017, and I've got the AWS Explorer open from our toolkit, which you installed. My mic not on? Ah, there we go, I think. Can you hear me now?
Rise the mic.
There we go. Is that better? No? Do I shout? All right. Can you hear me at the back now? Awesome. OK, right. I'll try and shout. So once you install the toolkit for Visual Studio, if you go up to the View menu, you get AWS Explorer. This gives you this window here with the services in. I've got an application here, a very simple application for Beanstalk that uses, there we go, Amazon Poly. I've actually already deployed it, so I'm just going to open up the environment. And we're just going to take a quick look at what this demo application does. It's very, very simple. And because it's using Poly, it's just going to read a phrase back to us. So, hello. I should have written, can you hear me now, right?
You've had all week to practice something. You're supposed to have something clever.
Listen. Hello from the stage.
There we go, right? Very simple application, nothing earth-shattering. But it does contain some code changes that we wanted to bring to your attention. So, starting with the startup file, you'll notice that we're now using dependency injection. So if you've been using ASP.NET Core a lot, you know this is a really heavily used pattern inside ASP.NET Core. So we made it really easy to use dependency injection with the AWS.NET SDK service clients. You get this support by adding a new Nougat dependency. And I apologize for the font size on the Explorer window. AWS SDK, .extensions, .NET Core, .setup. Because Norm cannot get enough dots in file names, apparently.
Naming is our hardest job.
So once you add that extension library, you get the ability to now add an extension method, add AWS service. It takes the interface type of the client that you want. In this case, we're using iAmazon Poly. And then if you look at the controller for this application, it automatically receives an iAmazon Poly client. Okay. The other change that we want to bring to attention was, if I can quite remember, oh yeah. Actually, while I'm here, I'm going to make a change to this. I'm going to change the voice to do a redeploy. Let's change it to Amy. Save everything. OK. So the other change that we wanted to bring to your attention, no, don't move. Thank you. Go back here, is configuration. So I've noticed, Norm, that in the demo app, you've commented out this line, add default AWS options.
Yeah. So when we first released this library, which was part of .NET Core 1.0, configuration was just a standalone thing. Often you put on the startup class. There was no global way to access it. And so to get the configuration in the dependency injection system, we always had that line that said, basically, let's copy the AWS configuration from your configuration system into the dependency injection so we knew how to create your service clients. Now, the .NET Core team realized when it came to 2.0 that everybody needs configuration. So they made the project system simpler in the fact that by default, they add configuration into the list of services in the dependency injection system. So now you no longer need to call that line if you've been using this library. Because what we're going to do in the code is we look to see, did you pass us any options? If you didn't, is there a configuration added to the list of services? And if so, pull the information out of there. So it simplifies that up for you.
So here's our app settings file. You can see in development mode, we have local credentials, local regions set. So when we're debugging locally, we get the AWS credentials to the app. But when we deploy, that drops away, and it's going to get credentials from the instance and the region. So that's the changes from the coding side, dependency injection and smoother integration with the configuration system. Let's take a look at deployment. So if you've seen us do demos on the toolkit before, you'll know that we can just right-click on the project, select Publish to Elastic Beanstalk. That launches the wizard. I'm going to get the right region here, West. I'm going to select to redeploy to Beanstalk. I'm just going to skip ahead to the end of the wizard. You're going to changes here. Save settings to AWS Beanstalk tools defaults.json and configure the project for command line deployment. So what this does is when the wizard runs, it will update a file with that name with the settings that you select in the wizard. And you can use that with the new .NET CLI extensions that we published today to publish from the command line or your CI/CD systems. So I'm actually not going to deploy from the wizard. I'm going to jump away to a command line. And here we are inside the project folder. And you can see that I already have the Beanstalk defaults file there because we published it earlier on. So let's see what we can do from the command line. So .NET EB is the tag, -- help. And you can see we've got 3 commands: deploy environment, list environment, delete environment. Let's take a look at the options for deploy environment. Put a tag in there. And you can see this would look familiar to what you've seen in the wizard in years gone by. In fact, you can interrupt between the wizard and the CLI tool. They'll work in sync. So that being said, as we have the file, let's just fire off a deployment. And we should update the voice to Amy.
And so this command, what it's doing is basically it's going to run .NET publish from the CLI, packages up, it generates the manifest file that we use to deploy it onto Beanstalk, and then it's going to tell Beanstalk, hey, you have a new version, go deploy this on the environment.
In fact, while that deploys, let's go and take a quick look at the file inside Visual Studio. So here is the defaults file. No, I don't want to move files. There's the defaults file. You can see the settings are in there.
And so all those got set by the wizard. So when we had that checkbox set in there, it got saved in there. So you can go back and forth between the command line and Visual Studio.
You can see the new versions deploying out to the instance. So how's it going at the command line?
Now, we got the tool, the .NET EB extension, because the other thing that checkbox does is it actually edits the project file in there. So if we open up the project file.
Well remembered, sir.
Mm-hmm.
OK, so we edit the project. And you'll see here this new .NET CLI tool reference.
So that's what the wizard did. By adding that checkbox, it installed that .NET tool in the project file. And so now when you do a .NET restore, which in .NET Core 2, it does a .NET restore as part of build, it's going to make that EB command automatically available for you on the command line. So there's nothing you need to install. You just set up that NuGet reference in there. And this is a tool reference, so it's not something that's included as part of your package bundle.
Let's see. OK, environment update completed. Let's go, and this time from stage.
Hello from the stage.
There's Amy. OK, so deployments from the command line, really simple. OK.
OK, so we took a look at some of the ways you can integrate AWS services in your application using that extension NetCore setup package and using the dependency injection. And we have that new .NET CLI extension for .NET Core applications so that you can easily go from Visual Studio and walk through how you deploy that. But then once you want to start doing things on the command line through scripts, or you're doing things outside Visual Studio, you can reuse that. OK, serverless .NET Core AWS Lambda. So this has definitely been our hot topic this past year when we released .NET 1.0. We have been working very hard for 2, and .NET Core 2 is coming very soon. I know everybody's very anxious. We are very anxious for it, too. It is getting very close. We're at the final testing stages for that. Now, what that's going to mean is the programming model actually stays the same. So your existing Lambda functions will be able to run on there, but you will need to update the target framework you're compiling for to be Net Core App 2.0, and you might want to update your dependencies to point to Net Standard 2.0. We are also going to include in the Net Core 2.0 Lambda runtime is the new Microsoft ASP.NET Core All package store. So this was a new optional thing that was added as part of .NET Core 2.0, where it actually is a cache of a lot of the NuGet packages already on the box. In this case, it's going to be all of the NuGet packages that you need for an ASP.NET Core application or using Entity Framework. And the benefit of that is that if you have an ASP.NET Core application that you're running on Lambda with our bridge library, and you have that ASP.NET Core All as your dependency, when you generate that package bundle, it doesn't include any of the ASP.NET Core app dependencies because it knows it's already in the deployment target. And you're going to get a much smaller bundle to upload to Lambda, as well as a smaller bundle for Lambda to download to compute. And if you haven't seen this before, if you go look in your Windows deployment folder.
Okay, so here's the .NET folder under Program Files. You'll see this store folder here.
So that was a new folder that was added as part of .NET Core 2.0.
If I drill into here, you see here are all the ASP.NET Core libraries. Okay, so that's the store.
And so speaking about the ASP.NET Core Bridge, that's the Nougat package we released, Amazon Lambda ASP.NET Core Server, that we demoed last year that showed you how you could run an ASP.NET Core web API on top of Lambda. And that we marked as preview, and we're going to retarget that to be .NET Core 2.0, because in the two environments where we're going to have the package store where we can get the better package bundle size, and we're also going to be able to have Razor pages working there as well, which is something that didn't work in the 1.0 solution. That's why we only showed web API. In .NET Core 2.0, we can do full ASP.NET Core apps through there. And so that's the environment we plan to GA. That bridge library is on the upcoming .NET Core 2.0 runtime. Now, one more thing I want to talk about is discussing the current pain I know a lot of people are having with our Lambda version right now, which is there's the versioning issue. In .NET Core 1.0, there is a lot of difficulty with what's called this meta package net standard library. This library is what all net standard libraries in the 1.0 and 1.1 world take a dependency on and essentially locks which version that net standard library can run on .NET Core. And what happened is most packages moved to 1.1, but our Lambda environment is still 1.0. And when you do .NET Publish, it pulls in those 1.1 dependencies in your bundle, which will not work in Lambda. Now, the good news is with .NET Core 2.0, and this is showing the maturity of .NET Core 2.0, they have removed that declaration of depending on a certain version of net standard library, which makes it makes more sense, really, because it's a net standard library. It shouldn't care which version of .NET Core, and that's what that does. Now, to give a better example of what I'm talking about, if we go look at Nougat, and let's go take a look at one of the Nougat packages out there.
Yes, let's go and take a look at the SQL data client. So system.data.SQL client. And if I bring up this package and then scroll through to the dependencies, if I go down to net standard 1.3, you'll see here's the dependency on that net standard library.
And the latest version of SQL Server Client is depending on net standard library 1.6.1, which means it only really works on .NET Core 1.1. So you have to go find a version of this library that has a dependency on net 1.6.0. But if you look down at net standard 2.0, you can see there's no longer that dependency anymore. So that makes that friction that's been happening along right now with the .NET Core 1.0 runtime go away. So we're very anxious to get to that new .NET Core 2 runtime. And so I know everyone is very anxious, and just to prove that we are really close to this .NET Core 2.0 runtime, we're going to show you a demo of actually using .NET Core 2.0 on a production endpoint.
OK, so here we are. Again, we're back in Visual Studio 2017. I have, again, another simple project, ASP.NET Core, but with Razor pages. If you look, you'll see that there's only a pages folder here. And if I open up the index file, I keep trying to move files. Here you go. If I open up the index file, you'll see this wouldn't be a reInvent demo from us too, unless we had to see Norm's family album from his latest trip. So this is going to enumerate through a set of photos, and then it's going to use Amazon recognition to apply labels to those images. So very, very simple. Let's go to the startup file, and you'll see that, again, we're taking advantage of the dependency injection support that we've added. But I've noticed, Norm, that you've added this add Lambda logger.
Yes, because when you deploy Lambda function, it always has a CloudWatch stream associated with it to get all your logging information. And all of the writes you do with the console.write line, or if you grab the logger from the iLambda context, those will go into that stream, that CloudWatch log streams. We also wanted to make it, if you're using ASP.NET Core applications on Lambda, to get it into that CloudWatch log stream. So we can do that by adding this log provider on there. And that means all the logging messages that's going through your ASP.NET Core framework will also go into the CloudWatch log stream.
OK, so Lambda and .NET Core 2.0 isn't the only thing that you guys have been asking about. You've been asking about X-ray support for .NET Core. So we're also going to be releasing that at the same time. And that, again, is a very simple task.
And if you don't know what X-ray is a service that was launched that enables you to instrument your application and be able to trace what's going on and see what services you're calling and how things are running.
Okay.
And we released the support for .NET Framework, but we hadn't had a .NET Core version, and that is coming soon with 2.0 support.
So here we have two new packages, AWS X-ray.recorder.handles.ASP.NET Core. So this one traces your ASP.NET Core flow. I'm going to install that into my project. Okay, and then similar one for the SDK. So you can trace the SDK client behavior as well. Okay, so the packages are added. So how do we wire this up? Well, the first thing we want is the ASP.NET Core tracing. And Norm, you have some opinion where this needs to go.
Well, you want to add the tracing as part of the pipeline that's handling HTTP requests. And that's defined in your startup method, or in your configure method in your startup class in asymmetric applications. And the order that you declare things in there is how things are handled in the pipeline. So you want to have it in there as early as possible so you can get as much of the tracing as in X-ray. But you do need to be careful to put it after the exception handling, because otherwise you won't get the exception handling into X-ray. So you really want to do it like right after that in your startup.
So this cunningly disguised blank line here should do it, right?
Very sneaky.
App.use X-ray. There's the new extension method that just got added. And I just need to give it a tag, reinvent. We'll look at that later on. OK, so that takes care of the ASP.NET Core tracing into X-ray. But what about the SDK?
So with the current version of the X-ray client that's out there for .NET Framework, basically what you do is every time you instantiate a client, you got to register with X-ray. And we really wanted to make that a lot easier to do, especially in ASP.NET Core's case, where you're not creating the client, you're relying on the dependency injection system to do that. So we basically just wanted to register X-ray globally for all of your service clients.
So I'm hearing from that we should do it very, very early on, probably in the constructor.
Right, because all the service clients that are created after the registration are the ones that will start sending the tracing information to X-ray.
OK, so I'm going to add that. I'm going to invoke an SDK handler here, courtesy of my new Nougat packages. Register X-ray. That's it. The SDK tracing is enabled for X-ray.
That's right. So that's all you need to do in the new version that's going to come out is add that line, and then all your service clients will now start sending tracing information to X-ray for you to get the service maps for.
So I think we can actually deploy this now. Now, the toolkit has not yet been updated to support the .NET Core 2.0 deployments, so we're going to use the command line. The sharp-eyed amongst you will have seen we already have the tools defaults file here from running previously. So let's just jump away to a command line. And same command that we saw last year, .NET Lambda deploy function.
So this is going to go do the .NET publish, build things up, send them to Lambda, and create a new application version. Now, when we demoed this last year, we showed you how to do it.
Oops, 1 second. I forgot to save the project. I knew this was going to happen. There we go. Gotcha.
I think you lost your Nougat references now.
No, we're good. They're there. OK. I knew there was another button I was supposed to press.
Can I go?
There we go.
OK. So last year, we showed how you would do this, and you would do the deploy serverless command where you would deploy via CloudFormation, which would set up the API gateway. Now, again, this .NET Core 2.0 runtime is not official or released yet, so CloudFormation doesn't know anything about that new runtime. So we have manually configured our API gateway to point to this Lambda function that we've uploaded.
Before we go take a look at that, do we want to take a look at the upload code size?
Sure.
OK. So over in here's the application folder that we were just in. If I drill into the bin folder, debug netcore app 2.0, you'll see that the zip file of the deployment is just 1.9 meg. Okay, and if I drill into the publish folder, you'll see that all of those ASP.NET Core references are just not there. So you're not paying that price.
Because we have that package store already on the Lambda environment, so you can have a smaller bundle.
So now let's go and take a look at the application. So here's API Gateway on our application. So drill into this. And under resources, you'll see that we've broken this apart, right? We're serving the static content, the CSS files and the JavaScript files from an S3 bucket. It's really not that efficient to serve that from a Lambda function. But our application is being served through API Gateway. And if I drill into the integration request here, you can see here's our Lambda function, US West 2, etc. So I think we should just go and take a look at that application. I'm going to click on Stages, beta here, and I'm going to grab this URL, paste it in here. I'm going to put my index page on the end.
So again, what this site is doing, basically it's doing an S3, list the buckets, calling detect image for each one of those images that it has, and figuring out what are all the labels on there, and saying what's in the picture.
OK. Enormous family labels.
Yes.
Humans.
I'm married to humans.
Let me refresh this. I love how you call your family labels. I think it's just awesome.
So yeah, we're going to refresh this a few times just to generate some X-ray trace information so we can take a look at that.
See, spaghetti for breakfast. That's a winner.
That's what you do on your birthday.
And miserable hobbits in the rain. So
if you're going to New Zealand, you have to go see the Shire. That's what you do. And we're from Seattle. We can take the rain.
They don't look like they can. OK, so that's generated some traffic. So you'll notice that those F5 refreshes were a little bit sluggish, right? So let's go and drill in and see what was going on. So I'm going to switch away to X-ray. It's computing the map. OK, so here's me. Here's our front end. And then the Lambda function, the calls to recognition, the calls to S3. So let's drill into that front end here and view the traces. And this last one, let's go for the most recent one. And you'll notice that here's that tag that I entered in the code. Remember the reinvent tag when I added X-ray? That's where it shows up. You'll notice here the call to S3 to list objects, and then 3 calls to recognition to do the labels. This is kind of telling me that my application, or your application, isn't architected that well, right? You should probably generate the labels on S3 ingestion, not when you're rendering the page each time, OK? So that's how you can drill into a Lambda function with X-ray. Back to the slide.
OK, so just to read again, .NET Core 2 Lambda support is coming soon. I know everyone is anxious. We are anxious for it. We just have a little bit more work we need to do. And we're also having X-ray support coming 2.0, and that is going to be only for .NET Core 2.0. So your existing Lambda functions for 1.0 won't work. There are APIs that we needed for X-ray that just weren't available in .NET Core 1.0. 2.0 is more mature, it has more APIs, and we're able to get that working there. We also had done a lot of work to improve how you set up X-ray for the SDKs to make it easier. Also, we needed a lot of work to support async operations in the X-ray SDK, which was critical for .NET Core since most all the operations are async. The bridge, once again, for running async applications on there, that's going to be retargeted towards .NET Core 2.0. Razor Pages has been an often asked feature for that, so that you saw is working. But again, if you're going to do a website through Lambda, I would highly recommend serving your static content through S3. Doing static content through Lambda, you could do it, but it's just not a very efficient use of it. And just like we saw in Beanstalk, we have that same CLI extension. So you'll be able to go back and forth between Visual Studio and a command line, or not even use the Visual Studio at all. You could just use Visual Studio Code or script it out. OK, and then the third part of our trilogy, the container-based .NET Core applications in ECS. So this is the new tooling that we released just about an hour ago, I think it was, we got it out the door. So this is going to be allowing us to run .NET Core applications through as container instances. And so in our first version of this tooling, what we're adding is the ability to publish .NET Core applications as Docker images to ECR, which then you can then push that to other services. But you can also, through the tooling, be able to deploy any .NET Core application to ECS as either web applications or batch jobs, or just you could run a batch job on a schedule. So say you have a large batch job you want to run on Sunday nights. You can have that all set up here. Now, these new container features that we released are only in Visual Studio 2017. That is where it has the new CS proj file format for .NET Core application. And that's really where we're going to be focusing a lot of our effort is on new tooling, is on the CS proj format. The project JSON-based one in 2015, we're not planning on doing any more effort other than supporting the existing Lambda functions there. This does require that you have Docker running on your machine and it's up and running. Because basically what our tooling is going to do is it's going to merge Visual Studio, Docker, and AWS all together to make it easy to use. Now, if you've never used ECS before, there are a few new resource types that you will come across. And the first is a cluster. A cluster is just the logical area where you want your work to happen. And it is usually made up of container instances, which are just EC2 instances, which will run all of your applications. And then you have a task definition that defines the Docker images you want to run. It includes any memory settings and CPU port mappings. All those things are defined in the task definition. And then the task definition, you say, I want to go run instances of that task definition in my cluster. And you would do that as more for transitory processes. Processes where the process identified in your Docker file, when that's complete, you want those tasks to end. Now, when those tasks start up, the first thing they need to do is they need to download their Docker image from the container registry. And we've optimized our tooling for Amazon ECR. You could also use Docker Hub as well. Now, the other way to run applications on ECS is as a service. And this is what you would do for web applications. Because when you run your tasks that are associated with the service monitors to make sure all those tasks are up and running. And if any of them die, it will automatically respawn new versions of those. So it's like monitoring your web servers, and if they die, make sure we create new ones. Gives you that redundancy. Now here, if those 4 or 5 tasks here were web servers, I'd have 5 different endpoints. So I probably want to tie those to a load balancer. And the service will take charge of making sure all of my service tasks are registered with my load balancer so that we'll have that one single endpoint, and it will spread the load of all the requests coming across all of my tasks. Now, in the keynote, we announced today Fargate as a new feature for ECS. That is the ability to now not have to manage any EC2 instances as part of my cluster. All I have to do now is just when I launch my task, say, I want this much CPU power and this much memory, and it'll take care of making sure you have the compute capacity needed for that. And that's how billing is done. So billing is done based on how much CPU, how much memory on a per second basis, with a minimum of 1 minute, I believe. And then, so now when we want to create clusters, it's much simpler if we don't have to worry about EC2 instances. All we have to do is just specify a name, and that's our logical cluster. And then when we launch tasks, we pass in our VPC configuration and an EC2 security groups. And we can also schedule tasks as well as one of our features, but scheduled tasks is actually handled by CloudWatch Events. CloudWatch Events has not yet been updated to support Fargate. When it does, then it will work. But right now, when you run scheduled tasks, you have to run it on a cluster that has EC2 instances. So with Fargate, that means that our cluster that we just looked before, those container instances go away. They're not our concern. Our cluster is just that black box that just takes care of running all of our tasks. OK, so now on to the third part of our trilogy. This is our time where we shamelessly plug to, I'm going to show the URL a little bit more, Steve.
I'm there.
Well, the URL. Oh, OK, so
I can't
to
click
get
the URL.
some feedback from you guys to see what we should be working on. This is a site we often demo where we have polls on there, norm-polster.com. And we're going to talk about how you actually deploy this application.
So if you have your laptops open, we invite you to tell us what we should be working on next year, and I'm going to redress the balance on that. There we go. All right. Should we show them how it architected?
Sure. So the 30,000-foot architecture view of Polster, there's really 2 moving parts to Polster. There is the serverless component, which actually works with AWS step functions to manage when polls are activated or deactivated, and works with DynamoDB. Unfortunately, we don't really have time to go into that part of the demo too much today. We'll be putting out a blog on how this works shortly on our blog site, and we'll share what the code is for that. What we're going to focus on is how we run that front end on an ECS cluster. I believe demo time.
OK. OK, so here we are inside the project, and here's Polster, regular ASP.NET Core application. We've added a Docker file, and if you've not used the Docker inside Visual Studio, it's really easy. Right-click the project, select Add, Docker support. Apart from that, it's all pretty straightforward in what we've seen earlier on. Let's go to the startup file, and you'll see that we're at dependency injection again. We have a different logging provider, though.
So in this case, what we've done is we released a package of libraries last year where we wanted to make CloudWatch logs very easy to use for .NET developers. So we integrated it in it with a lot of popular frameworks out there. So we integrated it with Log4net, nlog, Serilog, as well as the logging framework for ASP.NET Core. So in this case, we just had to add the provider into the ASP.NET Core's logging system. And so all of our log messages that we write as part of our application will go to our CloudWatch logs.
In fact, if we open up the app settings file, there's our log group, Polster Web. We'll take a look at that later on. I think, though, we should just get on with deploying this.
Let's do it.
So to deploy it, right-click. And you'll notice because it's an ASP.NET Core web application, we can still publish this to Elastic Beanstalk. But there's a new option, Publish Container to AWS. If I click that, it's going to launch the new Publish Container wizard. And we have a number of targets that we can deploy here. We can deploy it as a service, a task, scheduled task, or we can just push the image to ECR. So as this is a web application, a service is the most appropriate type. And you'll notice we have the options again to save the settings to a defaults file and enable the project for command line deployment. We'll leave that checked. So I'm going to create a new cluster. And we'll call it, give it the session name, DEV330. When we launch a new cluster from inside the toolkit, it becomes a Fargate cluster automatically.
The tooling we have in Visual Studio is only going to create an empty cluster. We don't have the tooling inside Visual Studio that will create a cluster with EC2 instances on it. If you want a cluster with EC2 instances, I recommend using the ECS's console that has a good CloudFormation template that they use to fill out EC2 instances in there.
So let's select a CPU. So let's go for the middle. And 2 gig for memory is fine. VPC subnets. So I'm going to deploy it to 3 subnets. And it's important that those subnets have internet connectivity, either through a gateway or a NAT.
It needs that gateway because it has to go reach out to go download the Docker image to be able to run.
And then security group, I'll pick the default security group for the VPC. So we're going to create a new service called Polster. I requested 3 subnet deployments. So let's go for 3 tasks, so it'll spread them around. We'll leave the rest as defaults. And we're going to configure an application load balancer. Create a new one.
And so ELB actually supports different types. It has the network-based load balancers and the application load balancers. The tooling we've added today is optimized for application load balancers. It has a really great feature where you have the ability to reuse the same load balancer for multiple applications and have it choose which target group to go based off of that path pattern. So we're deploying one application for the slash path pattern, but we could deploy a second application using the same cluster and the same load balancer and just say use /API to go to my web API one. It's important if you do that to make sure that the health check is always pointing to a valid path inside that cluster, because ELB is using that health check to determine if that task is healthy and if it can be registered to the ELB.
OK, so we're all good there. So let's move on. So let's create a new task definition. And obviously, our application is calling AWS, so it's going to need credentials. So we're going to give it a role. And it needs a task execution role because it needs to pull the images and talk to CloudWatch logs. So we have a role there. You'll notice in the port mapping, we're only specifying port 80. There's no container to host port map.
And that's because with Fargate, they always create for every task its own elastic network interface. And that means you also don't have that port conflict that you would often have if you're running multiple tasks all trying to access port 80. That would cause a lot of problems in EC2 instance. In this case, they each get their own elastic network interface, so every one of the tasks can be just running on port 80.
So I believe we are ready to publish.
Yeah.
Are you ready to keep up with the wizard output?
I'm ready.
All right. Publish.
OK, so this is now going to go set up our application load balancer. And we're going to start building the application. And after we build it, then we're going to create the Docker the Docker image. And after that, we log on to ECR to then push that image from our laptop here, which you would probably do it from a real CI system or something, to ECR. And then after that, it says, go create that service. And so since
the wizard beat you.
I tried hard. So since we created an application load balancer, that takes about 2 minutes or so to get provisioned. So why don't we go look at the console and see what we actually did in that wizard.
OK, so I'm going to jump to EC2.
I believe we have to switch regions. Is that right?
I am in US East 1. And go to load balancers. So here's our new load balancer that's been provisioned. And if we click on listeners, you'll see we have a single listener. Taking a look at the rules now, these correspond to the path that we had inside the wizard. And here's just our single path, default action for port 80. Just route everything to our Polster target group. Now sorry, go on.
So if we deployed a second application or any number of applications, those would each show up here as different rules to our listener, which would then target different target groups of ELB.
So let's click on the target group for Polster.
And the target group is where the tasks the ECS tasks are registered at. So I bet you, yeah, we don't have any yet. We're still spinning everything up.
Yeah. So CloudWatch logs?
Let's do the CloudWatch logs.
OK.
So we showed you how we turned on the logging. Steve and I have been practicing this talk, so we already have some logs already set up. So we'll look at that while things are being provisioned for us.
So here's the Polster web log group that we saw in the app settings file. Just pick one of these at the top. And you see all the output from inside the log.
Right, so this is all the default logging you really get with ASP.NET Core. So by adding that logging provider in there, ASP.NET Core is going to give you what the paths were called, the timing of everything like that. And I believe there was another log group that was interesting in there.
Yep, there's this ECS Polster one here.
Right, so this is the one that ECS has set up. So this log group is basically it's logging all the things that get written to the console. So the logger one we have is they're getting your logging that's actually inside your application. ECS is trying to get the log information that's just go to the console. So if something dies right away and it gets written to the console, this is a good place to go check to see if anything went wrong.
So let's jump back to EC2 and see how the provisioning is coming along. Load balancers. Actually, let me go into the target groups more so than load balancers. Targets. And there we go. We have our 3 instances split across 3 availability zones, all listing on port 80. So back in Visual Studio, if I refresh this view, the URL link to the application is now live. You can click that. And there's our Polster ASP.NET Core application running. So where's my favorite question on this screen? There we go.
I think it's my turn to vote.
Cool. So there we go.
We're from Seattle. We should be voting for Pearl Jam. That's our band.
I like the who are they. That's cool. So let's go back to Visual Studio. So I noticed, Norm, that you've added this Polster Reporter project.
Yes, we did, because we wanted to see what people are voting on, because I'm sure everyone is diligently voting on there to see what we're working on. And this is just a console application. So this is an example of how you can run not just web applications, you can run anything. So this is a bit of a batch job that goes and scans our tables and sees what the current vote is and send a message to SNS to what's the votes. And then we've got an email associated with that topic so we can see what the votes are.
Should we deploy this?
Let's deploy it.
OK. So I right-click. You'll notice I don't get the option to publish to Elastic Beanstalk because it's a console application, but I do get to be able to publish a container because the project has a Docker file. So this time, this is going to be a short-lived task, right? It's going to wake up, it's going to generate the report, it's going to send a notification and shut down again. So a task is most appropriate. But I think, should we run this on a schedule?
Yeah.
Again, I'm going to select to save the settings. And this time, I'm going to deploy it to an existing cluster because, again, it's a scheduled task, it's a task deployment. It needs CloudWatch events, which isn't yet wired up with Fargate. So it's an EC2 type. We've already created the cluster. Click Next. And we can either run this at a fixed interval, in this case every 10 minutes by default, or we can use a cron. Let's stick with the fixed interval. Here's the CloudWatch events role. Required. Move on. Task definition. Let's create a new one. Polster reporter. Memory, I know, 256 sounds good. Task role, ECS Polster. No port mapping because this is a console application. And publish.
So in this case, we're building it and we're creating the Docker image. And what we're going to do is we're going to go tell CloudWatch events that on this interval of every 10 minutes, go run this task definition. And that's the part that will be updated eventually to support Fargate, where we can say run it with these VPC configurations and such things.
So I go to schedule tasks. There's the Polster report that we just deployed. But I'm a little bit impatient. I don't want to wait 10 minutes to see what's going on.
So we could also just run it right away.
OK. So we saved the tools defaults file, right, inside the wizard. There's the new tool defaults. So instead of using Visual Studio, let's use the command line. So here we are inside the Polster reporter project. There's the files. So let's use .NET, ECS, help. Let's see what we can do. So we have deploy service, deploy task, deploy schedule task, and push an image, just as we saw inside the wizard. Let's take a look at the options for deploy task. That's a lot of options, Norm.
Yeah, because there are a lot of things you can actually specify with container images. And in the wizard, we just optimize for what are the most common things you want to set. You can always add any of the other settings in that JSON's file, and when you deploy through the wizard or the command line, it'll pick up those settings. So it's sort of the backdoor for the more advanced settings when you go through the wizard.
OK, given that we already have the file, I'm just going to deploy the task. And this output should begin to look familiar by now.
So in this time, instead of saying CloudWatch events run this task definition, we're going to go say to ECS, run task with this task definition.
Done. It's out. OK, let's go back to Visual Studio. And if I open up the cluster, instance cluster, and we look at tasks, currently pending, cool. Do a refresh. It's done. There we go. It's already run. So if we go to our email, there's the notification. There's the votes.
All right.
Cool. OK, back to the slides.
OK, so we talked we showed briefly about how you use CloudWatch logs with .NET Core or with .NET libraries. There's some for .NET Framework and .NET Core. We have a blog on our blog site that talks about those, so highly recommend checking that out. We also worked on deploying an ASP.NET Core application to our ECS cluster with Fargate. So that took care of setting up all of our compute needs, and it was easy just to set up the cluster, the service. We did the application load balancer. We also did just a console application, and this we did with CloudWatch events as well as through the command line. And just like we saw with Beanstalk, Lambda, and now this, we have that CLI extension. Because this is the pattern we're trying to do is any of the tooling that we add to Visual Studio so you can go through and walk through is we want to make sure you can take that out of Visual Studio into other environments like Visual Studio Code or just in your scripts. OK, so that's what we wanted to cover today. Just to recap here, we have that .NET extensions. Check out that GitHub repository. It has a lot of information about all the available options on there, how to install it if you're not using the wizard, to add that checkbox in there. We talked about how you can add AWS services in your ASP.NET applications with that extensions library, as well as with our CloudWatch loggers. Beanstalk, we have the new option to be able to set up this new CLI extension. Lambda, again, .NET Core 2 support is coming soon, along with X-ray support. So those two highly requested features are coming soon. And we showed the deployment through the command line. And ECS is the new features we just released this afternoon. So you'll see new versions of the Visual Studio Toolkit on the marketplace. And that you can deploy any type of application as a .NET Core, any .NET Core applications as containers out there as services or tasks or scheduled tasks. And with that, this is finishing up. This is a couple things. Check our Twitter handle or our blog site. This is where we have all our information we come out, especially as we come, the .NET Core 2.0 is coming out soon. We'll have a lot more information about that on our blog site. The following GitHub repositories are GitHub repositories that Steve and I work on a lot, along with the rest of the team. So if you have feedback or questions, good place to end GitHub issues or reach out to us. And with that, thanks.